Yeah, so this is going to be a video about how to make a function block, which is a program element in a CPU. So if we have a little look at our project again. So when we installed it under program blocks, if this one is not expand the CPU, expand program blocks. So what he did here was he inserted main. We can look at the main. A main is a task. And this main here, which is called organization block 1, is a cyclic task. It executes. Basically what it does, the operating system does, is it's a input from all my input modules, input data, process this data, and write to output modules. And afterwards, it says the data you have processed, output to the output modules, and then restart the program. We can look at this one. It's a double click, right click or open or whatever. I use double click, and it inserted it in ladder logic. And ladder logic is some legacy program language from the 70s and 80s. It's still being used, but you can't make robust programs with ladder logic. It's difficult. And advanced programs also difficult. What you can do here in ladder logic is you can switch it to something called function block diagram, which is it's a different program language. That's legacy for German PLC programmers. And here you have got basic instructions, what you call instruction you can insert here and work on. This course is not about FPD programming or ladder logic programming. We are going to program in structured text. So ladder we don't like. I don't like. Delete it. So now what you can do here is you can make also, this is a context menu, got to know it, add new group. A group is a folder. Let's say introduction. Whatever. It's kind of nice to organize the program here. And then you can double click add new block, or you can use the context menu here and say add new block. I need a task. That's an organization block, and I will call this TSK background processing or something like that. But program cycles, ladder, I don't want it. I want SCL, which is structure command language or control language, they call this. This is the structured text the Siemens says. It's not completely compatible with structured text as laid out in the PLC open norm, but it's structured text. And OK. So now I got a task background. So I want a function block 2. A new block. Function block here. FB. We can call it pulse generator. Again, ladder. In the setting, you can alter this so it your preferred language. I guess TI Portal is going to remember your last selection. Yeah, let's generate. So now you have more tabs down here. Now we can look at the task background, look at this, and I had device configuration if I need that. I'm not going to use that anymore. So I'm just going to look at the FB. So a function block has inputs, outputs, input outputs, read and write to them. We store static data, that as long as there's power on your CPU, these data, the last value you wrote into a variable here, is going to remember temporary data. It's not going to be remember and constants. So we're going to try to use all of these. And then down here, you have a code section. I'm just going to complete on this. And here you have got properties. So you can look at properties for your function block. So what you can do, name of your function block. There's probably on the input I was, let's say, if I click up here. Well, a function block has properties. You can get access to them here. The title, who made it, a version, a family, I don't know who wrote it, user-defined ID, we could call it just FP pulse generator, and so on. But now we are going to program. Input, we are going to use an input called XE. It's going to do Boolean. I use a tabulator. Not going to look at it on the HMI. Enable pulse generator. Output Y. You can also set up this so you don't get this as a default. Pulses. I haven't done that. I used pulses. In-out we are not going to use. Static. Well, we are going to make, we have to have a timer system. We are going to call some st time. And the static time type, so it has to be time. Tabulator, this gets annoying, so you just go in and store time. That's what I'm going to use it for. Now I won't need something that's called actually TT now. Again, time. Temporaries you can't put on an HMI system. Oh yeah, time tick now. Probably use, we are using camel case and Hungarian notation. TT time. Now we're going to remember I had time, so I used too many tabs for time calculation. Not four pulses. Constant. I need a constant, but I'm not going to follow now. Well, as it is an FB, let's see. I suggest enable. We are not going to make pulses. So now we should probably have a temporal here or a static. You make those as you go along, but I'm just going to write if not XE, then return. Return, abort the program, and if. I'm not going to do anything. So what do I want to do now? Maybe not. I shouldn't do this because I want to make pulses. I want to prepare some, populate. Probably temporaries. Of course, you can make this a little, that is just the control test and the scroll wheel on the mouse. There's a lot of populate. TT now and tab, of course. I wrote, so he fixes my names. Time tick. That's a permanent function. It's going to give me the number of milliseconds since for 24 days. It's a 32-bit integer value, plus or minus, but it counts from 0 to maximum, which is not that nice. Now it changed a little over here. So I used a firmware function. No, this is built-in, so it's not going to show this one. I should say once in a while, in case my program crashes. 19 doesn't crash often. Earlier version crashed quite a bit, and then you lose your work. TT now. So so if it's not enable ST time tab, and some tabulators. You can set this up. Now I like to have my assignments in a column lined up. But TI Portal can organize your structured text program for you. Then it will just fix it. So it is in Tools and Setup. So it's in Options there. TT now. Return. No pulses. Yeah. I should only write to an output once. SBY. Boolean. Yeah, it isn't Boolean, it is BU. Bool. And again, annoying. Get rid of it. I keep it because when you program, maybe a lot of programs need something on the HTML. Yeah, output. Yeah, but then I shouldn't use my return statement here because I want to write. So it's not enable. I want no pulses. SBY. False. I need to remove my return because down here somewhere I want to write. You should with probably a W2. Why? SPY. It has to be static. That's the reason why I'm making FP. Well, too bad. Else. Yes, I get a red underlined. I can put in no operation. So what it can do now, I can try to compile it. That's up here. Compiles. So this is the semantic ML is looking at. Maybe I should not download, I should compile. This is what happened when I download. You want to say, find your CPU. Where do you want to download your program? Was the FP1, let's say, here are warnings and information and so on. Yeah, you would get those errors. So it's error free so far. Well, what I'm going to do, TT time. TT now. This is a free running pulse minus the time I stored or I saved. Now this one can be negative. So you have to check. We don't like negative times. If time less than, not less or equal, T hashtag 0 second. So this is a constant in SCL. Use parentheses. So then I have to wrap it. I have to add to my TT time. Then you should double click, paste. I have to add something to it. The value, I have to wrap it, plus, if I find a plus, 16, hexadecimal, 7, 3 Fs, 4 Fs. It's not a time value. Too bad. I get then, but whatever. And if and then a semicolon to need a little more space. Didn't like it. first it should be a constant. What is this? And it doesn't like it. Let's say if we say this is a dint to time, the time value is t hashtag. It's 24 days and something. You'll find in the manual, like this one. But still, it's a number. It shouldn't be in the program. CT maximum time value, which is of let's say it was dint worked conversion value. Of course, we can copy from here to here, not B. Let's compile V. I push Control B, which is compile. Maximum scale 0 to milliseconds or something like that. And let's just make it a little more easier to read. Yeah, maximum time value. So if this TT time, copy, parenthesis, is equal to T1 second, then I want to make process easy, SPY, a little too far, not SPY. Yeah, then we have to close the end statement. And if. Pretty much no comments here. I'm not going to write much comments. Just write to outputs, maybe make a little space do whatever. Yeah, you do whatever you need to do with your program. Say project, compile. Okay, it worked. That was the pulse duration here. Maybe I want to make it a little more specific or more general, so I want to specify it. So from input PPD time, here we can put a default value T hashtag 1 second. What I have down here. I want to make this retain. Retain means even if I switch off my CPU power, lose CPU power, it's going to keep this value and the power get back on. And then is so it's going to be a 50% duty cycle here when we did a not. So I want to use this one, make it a little general, and that was down here. We could call this 0 time, but it's pretty obvious. This is 0 time, so we don't use a name for that one. So that is my FB. It might work, I don't know. I have to test it. I'm going to do that later on. It's just an FB. So I populate temporaries. The TT now I have to get a value for, and if it's not enabled, I just keep my save time running. So when I start, I'm just going to get I get a 0 and then I can pulse. ST time is now, that one is false. So it's not enabled. It's going to jump down here and output my memory. If not, I calculated time. How many ticks have I got since I last saved it? And then I calculate here, less than, TT time, rapid if it's negative. Okay, here we have a problem. Because if I want to start to recount, I need to say ST time is TT now. Because I have to start at 0 here again. I would have found it on the test, of course, that it wouldn't work. So we need to make a comment. system, for instance. Restart timing systems. This looks pretty okay. So yeah, so that was an FB. So what I did was that I was going to make a simple program. I deleted my organization block because it was in ladder logic, and then I wrote the FB itself. Still, I haven't called my FB. I haven't used it yet. That's going to be a later video where we are going to test it, test the function block itself. Yeah, and the function block is going to output some pulses, a square wave with a duty cycle. I don't specify the duty cycle. I specify the on time, or how often the output is going to change.